The purpose of this video is to do a mini review on the information that we used last year while working with algebraic expressions and a little bit with solving equations. So before we focus on the traditional method, we're going to be using flowcharts again. Flowcharts can be used to evaluate an expression. So if you just have an algebraic expression, for example, let's say 5t subtract 3, when t is 6, we could substitute in 6 for your variable t and get a value for that expression. We can also use a flowchart to solve an equation. So if I had 5t subtract 3 equals 7, I could use my flowchart with backtracking to solve for the unknown value of t. So last year when we first started talking about flowcharts, we said that we had bubbles and we had action arrows. So a flowchart's always going to start with the variable in the first bubble and determine our actions based on the operations that will be used on that variable. So in the expression here for x, we just have a one-step expression, and we can use our flowchart, an action bubble, a bubble that's going to start with our x, and then we're going to have an action arrow. If I can get my arrow to move, action arrow, and on that action arrow we should be able to say that we want that to be multiplied by 4, and we're going to need another resulting bubble, which is the result of the action and the previous bubble. So x times 4 is going to be represented then as 4x. Remember, in math we're going to be focusing on using our coefficient, the number, written before our variable. So it's going to be 4x and not x4. So as you're watching this video, you might want to have a piece of paper out in front of you and draw these next few expressions using flowcharts, and then we're going to practice with solving these same expressions that will be set equal to something. So in the expression 4x plus 3, we actually have a two-step expression. My first bubble is going to have x. I'm going to then have one action arrow, another bubble, another action arrow, and that last bubble. So if my first bubble was an x, my first step following order of operations in the expression is going to be multiplication. So my first action arrow is multiply by 4. The resulting bubble is 4x. And my last step is going to be to add 3. So the last bubble is going to be a representation here of the previous bubble and the action arrow. So my last bubble will have 4x, oh, I lost my pen, 4x plus 3. So let's say we want to know what the value of the expression 4x plus 3 equals when, let's say, x is equal to 4. So what that means is we're going to flow forward or flow to the right in the direction of our arrows. So I'm going to go ahead and pretend that I'm going to substitute in this 4 and just kind of put it into that first bubble. So if I take and use 4 as my x, I can have 4 times 4, and the resulting bubble would have a value of 16. And then I can add 3 to the 16 and have 19. So if we look at that using the traditional method, we have 4x plus 3, semicolon, to indicate that x is going to represent 4. And now we can substitute in 4 times 4 plus 3, funnel down for 4 times 4 is 16, plus 3 gives us 19. So that's seeing that we're using the traditional method, or the funnel method, is going to give us the same result as using this visual flowchart. So now let's start with this negative 3x subtract 5 and evaluate the expression when x is going to be, let's say, 7. So we're going to do 7 multiplied by negative 3. Gives us negative 21 based on our integer operations from last unit. And now we have to subtract 5 from negative 21. So this is where, if you need to, you're going to use a corner of your paper to do negative 21, subtract 5. Remember to think, act, do. So we think addition, use or act like its opposite, so that 5 becomes a negative 5. And then lastly, add. So negative 21 plus negative 5 is going to be negative 26. So negative 3x, subtract 5, when x equals 7, is negative 26. In the next expression, we have negative 3x subtract 5. So even though there's a negative in front of that 3, we can still start by building our flowchart. This is a two-step expression. We should see that we have multiplication and then we have subtraction. So you're going to need 2 action arrows, but you'll need 3 bubbles. So my first bubble, first action arrow, which will be multiplication, the result of the variable and the multiplication, my subtraction arrow, and then the resulting bubble, or the final bubble. So if we build this together, I'm going to start with the variable. My first action arrow is multiplication by negative 3. The result of that variable multiplied by negative 3 is negative 3x. Subtract 5 is my next action arrow. So my last resulting bubble will be negative 3x subtract 5. Upon first glance, this expression, 2 times the quantity of w plus 3, or 2 times the sum of w and 3, looks a little bit tricky. But we still have to remember that we're going to follow order of operations, which means we have to build our flowchart also using order of operations. So if I take a quick look here, I'm going to have to add first, and then I'm going to multiply. So I still have 2 action arrows and 3 bubbles. So bubble, action arrow, bubble, action arrow, and bubble. And now I can start to build this in. My flowchart always starts with a variable. So my variable is w. The first thing that has to happen to w this time is to add 3. The result is w plus 3. Now I have the quantity in my parentheses, and I'm going to use my last action arrow to multiply by 2. So my last bubble is going to be 2 times the quantity of w plus 3. So to use the expression 2 times the quantity w plus 3 in our flowchart, when w is, let's say, 8, we just flow forward. 8 plus 3 is 11. 11 times 2 is 22. So 2 times the quantity w plus 3 when w equals 8 can also be looked at with the traditional method, substituting in 8 for w, and then following order of operations. 8 plus 3 is 11. 11 times 2 is 22. Take a moment before going on to the next part of this video and look to see if you can't find where we have the same steps happening in the traditional method or the funnel method along with our flowchart.